Welcome to lecture 3 of module 4. We are going to discuss on the topic internet control protocol. We have already learned about the IP protocol. In that we have seen that when nodes want to transfer data, okay, this is one node, this is another node. When they want to transfer data between them, this data is integrated in an IP packet. Okay, this is an IP packet, and this IP packet we are integrating our data in this IP packet. This IP packet contains the header part and data part. So we are integrating all this data into this IP packet. Okay, there is a problem with this IP packet. This IP packet does not have any error reporting mechanism. Okay, so that is, if any error has occurred in this while transferring during the transference of this IP packet, the error reporting is not possible. Error reporting is not there in this IP packet. Okay, so in order to integrate this error reporting mechanism into error reporting as well as correcting mechanism into this IP packet, we are including some protocols. That protocol is called internet control protocols. Okay, so in internet control protocols we are going to study a few protocols. The first protocol we are going to study is the internet ICMP. Okay, internet control message protocol. Okay, so let us now discuss the introduction to internet control protocols. Okay, as I said, the IP or internet protocols have no error reporting or error correcting mechanism. Okay, so it does not have any error correction or reporting mechanism. That is, IP protocol has no built-in mechanism to notify or error correcting when error happens. The router must discard the datagram. Okay, so if the error is happening, there is no mechanism to report that error to the source, or there is no mechanism to correct those errors. Okay, so if an error is occurring, the main role of the router is to discard that datagram or discard that packet. Okay, if error is occurring, they have to discard the datagram. That cannot be happened here. Okay, so therefore, in addition to a IP, in addition to the IP, internet control protocols are used in the network layer. Okay, so in addition to this IP packet, we are actually integrating a internet control protocol along with this IP packet. Okay, this is actually implemented in which layer? It is actually implemented in network layer. Okay, for what purpose it is implementing? For flow control and error control. Okay, so flow control, what do you mean by flow control? Well, the transmit the packet or transmit the datagram from source to destination without any issue. Okay, we have to maintain the flow. Okay, so error control and also error control. If an error happens, that has to be reported. Okay, both the flow control as well as error control is handled by this internet control protocols. Okay, so where this internet control protocol is existing, it is existing inside the IP packet. Okay, this is actually integrated along with the IP packet. It is a part of network layer. Okay, it is used for handling flow control and error control. Okay, use of internet control protocol, we can make reliable data delivery. Okay, so we can increase the reliability of the data transfer by introducing this concept, internet control protocol. Okay, so reliability of the packet can be increased. Clear? Now let us see the different protocols that we are going to study. Okay, so the main internet control protocols that we are going to study is internet control message protocol, ARP, address resolution protocol, RARP, bootstrap protocol, and dynamic host configuration protocol, DHCP. Okay, all these protocols we have to discuss. Okay, so today in this lecture we are going to discuss about the internet control, the first one, the internet control message protocol. Okay, so let us go into the internet control message protocol. So the same thing we have explained, okay, that is being repeated here. Since IP does not have an inbuilt mechanism for sending error and control messages, it depends upon the internet control message protocol. Okay, so as I said that IP does not have a mechanism for sending error and control messages. Okay, for enabling this, making this error and control message transference, we are using this internet control message protocol. Okay, it is a supporting protocol used by the network devices like routers for sending the error message and operational information. Okay, so it is actually a supporting protocol. It is a protocol that is supported by each and every hardware, okay, in the network. Okay, this protocol is actually compatible with each and every hardware devices like routers, okay, for sending the error message. Clear? So this ICMP messages are being classified into two. There are two types of messages. First one is error reporting message and second one is query message. Okay, so error reporting message means we are just sending if any error occurs, that error is being reported to the source. Okay, query message is actually for requesting for some application, requesting for some purpose. Okay, requesting for some activities. Okay, if the source if a node wants the IP address of the destination, he can request by a query message. Okay, so such type of messages are called the query message. Okay, if any error occurs, the error message has to be reported. That message is called error reporting message. Such messages are coming under error reporting messages. Okay, so let us go into the details of error reporting messages. So error reporting messages, they are having 5 classifications. Okay, we are having 5 type of error messages. First one is destination unreachable. Okay, source quench, time exceeded, parameter problem, and redirection. Okay, these are the 5 types of error messages that are occurring here. So destination, so each of these error messages are having different types. See, type 3, type 4, type 11, 12 and 5. Okay, so what is the purpose of these types? In this ICMP message format, there will be a field called type. In that type, we can write this value. For destination unreachable, we will be writing the type 3. Okay, for source quench, we will be writing 4. For time exceeded, it will be 11. Parameter problem 12. Redirection 5. Okay, so let us go into the details of each and every messages. Okay, now, first one is source quench. So what do you mean by source quench? We will explain it using a figure. Look at here. So here this is the source, this is the intermediate nodes, and this is the destination. Okay, so here the datagrams are coming. Okay, and these datagrams are being transferred from source to destination through these intermediate routers. Okay, so look at here. See, here the source is sending 3 datagrams at a time. Okay, so here they have here we are having 9 datagrams. Okay, so a router or a router can process only suppose in this scenario it is saying that the router can process only 3 it can collect 3 datagrams and can process only 3 datagrams at a time. Then you can transfer this 3 datagram to the next neighboring router. Okay, but here look at here more than 3 routers have been reached here. Okay, so this router 2 cannot process this 9 datagrams. He can process only 3 datagrams. Okay, so what this 2 does, the 2 will send a ICMP message to the source saying that there is some congestion is here, there some congestion has occurred here, and here he is going to discard the extra packets. Okay, so why he is going to discard? Because he is having a queue here. That queue can accommodate only 3 datagrams, but here 9 datagrams are coming. So rest of the 6 datagrams will be discarded by this 2. Okay, so such a message will be transferred to the source. Okay, so that is what is written here. ICMP informs the source that 2 is congested. Okay, so 2 is congested and the packet is discarded. Okay, that message will be given to the source. Okay, so it will send 2 types of messages. First is what it will say that this packet, there is a congestion has occurred here and the datagrams has been discarded. That is the first message. Okay, second message say that the congestion has occurred here and you have to slow down the transmission rate. Okay, കുറച്ചുകൂടെ പതുക്കെ ട്രാൻസ്മിറ്റ് ചെയ്യണം. അവിടെ കൺജഷൻ വന്നു കഴിഞ്ഞു, അവിടെ കുറച്ചുകൂടെ സ്ലോ ആയിട്ട് ട്രാൻസ്മിറ്റ് ചെയ്യണം. You have to slow down the transmission. Otherwise there can be more congestion in the future. Okay, so these 2 messages are sent from the router to the source. Okay, so this is an ICMP message. Okay, now we will go into the explanation. If the datagrams are received by the router much faster than they can be forwarded or processed. Okay, so here more datagrams have reached here. It cannot handle all these datagrams. Okay, some will be lost. Clear? So in such cases what it does, it cannot forward or process. The queue may be overflown. Okay, as I said, here in each packet, each router they will be having a queue. That queue will be overflown. In this case, the router or the host has to discard some of the datagram. Okay, here in that case, the router or the host will eliminate such datagram. Okay, so when a router or a host discard the datagram due to congestion, it send a source quench message. Okay, if it discards the packet, what it do? He will send a source quench message to the sender. Okay, source quench message to the sender saying the two details. What are the two details he is going to send? First detail is datagram has been discarded. Second message is saying that it warns the source that there is a congestion somewhere in the path. There is a congestion and the source should be slowed down. Okay, slow down or quenched. Quench means we have to decrease the rate. Okay, slow down the sending process. Okay, this is called the source quench message. Clear? You can explain it using this figure. Now parameter problem. So when a packet comes to the router, then calculated the header checksum should be equal to the received header checksum. Okay. So as I said that the IP packet will be having two parts. IP packet will be having two parts. One is header and one is payload. Okay, payload means data. Okay. So when a IP packet comes, it has to check the header, whether the header is there any error occurred at the header. Okay, for checking the header, we are having a header checksum. Okay, since this header will be having some bits, okay, that checksum will be is with the IP header. And at the receiver side, they will again compute the checksum. Okay, they will again compute the checksum. If the received checksum is equal to the computed checksum, then it means that the header does not have any error. Okay, but if there is any variation in the checksum, then the error has to be reported. Okay, that is called a parameter problem. Clear? So if there is any error in the checksum, that has to be reported. That is called a parameter problem. Clear? So whenever packet come to the router, then calculated header checksum should be equal to the received header checksum. Okay, then only the packet is accepted by the router. Only this header checksum is right, the packet will be accepted. Okay, if there is a mismatch between the packet, will be dropped by the router. Okay, if there is a mismatch between the header checksum, then the packet will be discarded. Clear? That is called a parameter problem. Okay, clear? So noise modified IP header. So check the checksum. So checksum will be done, and if there is a error is there, then that will be discarded. Okay, that is another message. Okay. Next is time exceeded message. So each datagram contain a field called time to live. Okay, so each datagram is having a parameter called TTL, time to live. Time to live means the expiry time. Okay, ഓരോ ഡാറ്റാഗ്രാമിന് അതിന് എക്സ്പയറി ടൈം ഉണ്ട്. ഓക്കെ, അപ്പോൾ ആ എക്സ്പയറി ടൈം കഴിഞ്ഞ് കഴിഞ്ഞാൽ ഇഫ് ദ എക്സ്പയറി ടൈം ഓർ ടൈം ടു ലീവ് എക്സ്പയർസ്, then it cannot send the or forward the datagram to the next neighboring router. It will be stopping there. Okay, this is the functionality of TTL or time to live. When a datagram visits a router, the value of the field is decremented by 1. Okay, so each time when the datagram visits a router, the TTL value will be decremented by 1. Okay, clear? So look at here. Here the TTL value is 2. Okay, so when it reaches here, when it reaches the router 1, the TTL value will be 1. Okay, so when it when it reaches router 2, the TTL value will be 0. That means that the validity of that particular packet has been expired. Okay, in that case, the router 2 will send an ICMP message saying that the validity of the or the time to leave has been expired. Okay, in this case, what the TTL value was 3. When it passed to this router 1, it has been decreased to 2. When it passed to router 2, it has been decreased to 1. Okay, when it reaches here, it has been decreased to 0. Okay, so as soon as the TTL value becomes 0, here the host B will send a ICMP message to the source saying that the time has been the expiry has been happened in the particular datagram. Okay, that is called a time exceeded message. Okay, this is another type of ICMP message. Clear? So we have already told about the source quench message, then the parameter problem message. If the header has an issue, that also must be reported to the source. Then here it is, if the expiry of the expiry of the datagram or the packet happens, it must be reported to the the source. Okay. Next is destination unreachable. Okay, destination unreachable means if there is any failure in the connection or failure in the link, that has to be reported to the source. That is called a destination unreachable. So destination unreachable is generated by the host or its inbound gateway to inform the client that the destination is unreachable for some reason. Okay, so here the packets are coming. It has reached from source to the router 1. So from router 1, it's found that there is a link failure failure between 1 and 2. Okay, so it also found a hardware failure between 2 and 3. So here they have found a port failure between 3 and the destination. Okay, so these informations will be passed on to the source through a ICMP message. That is called a destination unreachable message. Clear? The last one is the redirectional message. Okay, so redirectional request data packet to be sent on the alternate route. Okay, so look at this figure. So here we are having a router or host A. The host A want to transmit a packet to source host B. Okay, so the best optimal path is from router 2, it has to pass through the router 2 and then to the destination. Okay, but he knows that this is the optimal path, but he will take this route. Okay, this IP packet will be transferred through router 1, then router 2 and to the destination. Okay, so when this packet, when this host sends this packet to the router 1, reaching at the router 1, it identified that this R2 was the optimal path. Okay, he could take in this path. Okay, that will be understood by this router at that time. Okay, he is aware of that route only at that time. Okay, then what he does, he will correct he tell a correction message to the host A saying that next time you can take this route. That is called a redirectional message. Okay, so A is sending a packet to host B. Okay, so actually this is the optimal path from R2 to the host B, but he took this route. He taken from this R1, R2 and then to B. So when the packet reaches R1, this R1 found that this transferring through this R2 was the optimal way. Okay, so that message will be transferred to the host A through this redirectional message. അതായത് ഇനിയിപ്പോൾ R2 കൂടെ ഇനി അടുത്ത മെസ്സേജസ് എല്ലാം R2 കൂടെ പോയാൽ മതി എന്നുള്ളത് ഈ റീഡയറക്ഷണൽ മെസ്സേജ് കൂടെ അവരത് അറിയിക്കും. Okay, that is called redirectional message. That is informing about the alternate route. Okay, a redirect request data packet to be sent on an alternate route. The message informs to the host to update its routing information to send the packet on the alternate route. Okay, so it is requesting the node A or host A that it must update the routing table, that the next alternate route is this one, optimal route is through R2. Okay, clear? That is called a redirectional message. Okay, so these facilities are not available in the IP packet. Okay, to improve this efficiency of the IP packet, we have integrated an ICMP. Okay, clear? Next, query messages. Okay, we have completed the error reporting messages. Okay, we have completed the error reporting messages. Error reporting messages are destination unreachable, source quench, time exceeded, parameter problem and redirection. Okay, now we are going to the next part, that is the query message. So query messages are used to diagnose some of the network problem. If it have to check any connection, if a host A want to check that the connection is established, connection is there between host A and host B. Okay, he can have a query message. Okay, he ping message, pinging. Okay, if he want to check whether the other host is responding, he can just ping by using the IP address. So ping is just a query message. So there are four different pairs of messages. Okay, so echo, request and reply message, that is one type of query message. timestamp request and reply message, then address mask request and reply, then router solicitation request and router solicitation and advertisement. Okay, these are the 4 different types of message. Okay, so echo request and reply is the example that I have just told, that is pinging. Okay, pinging means if there is any, if a host want to know whether any connection is there with the host B, host A and host B, he can just ping using the IP address. Okay, that is called echo request and reply. So echo request and reply determines whether two systems, host or routers, can communicate with each other. Okay, they are having a connection, they can communicate with each other. To checking whether they can communicate with each other, that is using example ping. Next is timestamp request and reply. Two machines can use the timestamp request and timestamp reply message to determine the round trip time needed for the IP datagram to travel between them. So timestamp request reply is actually a message that is sent from host A to host B and then host B to host A. Why this is done? This is done to determine the round trip time. Okay, അവിടെ നിന്ന് പോയി host എന്ന് എയിൽ നിന്ന് ബിയിലോട്ട് പോയി തിരിച്ച് വരാനുള്ള ടൈം. Okay, the time take to compute the distance from A to B and then B to A. Okay, for determining that we are using this timestamp request and reply message. Okay, to compute that, to determine the round trip time needed for the IP datagram to travel between them. Okay, ഒരു IP ഡാറ്റാഗ്രാമിന് ഹോസ്റ്റ് ചെയ്യുന്ന ഹോസ്റ്റ് എയിലോ ബിയിലോട്ട് പോകാനുള്ള ടൈം എടുക്കുന്ന എത്ര റൗണ്ട് ട്രിപ്പ് ടൈം എന്നുള്ളതാണ്. That is called timestamp request and reply. Clear? Next is address mask request and reply. A host may know its IP address, but it is not aware about the corresponding mask. Okay, ഇപ്പോൾ ഹോസ്റ്റിന് an IP address, they may be knowing its IP address, but they are not aware about its mask. Okay, to obtain the mask, he can obtain the mask using this query message, that is address mask request and reply. Okay, to obtain his mask, the host can send an address mask request message to the router on the LAN. Okay, so he can request the LAN router for the mask and he will reply to that. Okay, that is called address mask request and reply. Next one is router solicitation and advertisement. So here it is saying that a host that wants to send the data to a host on another network needs to know the address of the router connected to its own network. Also, the host must know if the router are alive and functioning. The router solicitation message and router advertisement message can help in this situation. Okay, that means that here we are having a node, okay, or a host. So this host is under this network. This is a network. Okay, so it is having many hosts. Many hosts are connected like this. Okay, and he want to connect to another host. This is another network, and he wants to connect it to this network, this host that is connected to in another network. Okay, for connecting these two networks, we are having many routers. Okay, we are having many routers. Okay, so this host, host A want to communicate with the host B, want to send a packet to host B. Okay, so this host B is in another network, so he has to pass through all this, these intermediate routers. Okay, this network and this intermediate routers, and only he can reach to B. Okay, suppose this host A want to know the IP addresses of all these routers. Okay, if he want to know that, he can just say just give a router solicitation and advertisement message. Okay, so the router solicitation message is actually broadcast, is a broadcast message. It is be given to each and every node. Okay, in reply, the particular host, so this broadcast message will be reaching to each and every node, this router and everyone. Okay, so when this router reaches this, when that message reaches this router, the router will respond to this host A through a unicast message. Okay, clear? It can be a unicast message. Clear? So this is what explained here. A host that want to send a data to a host on another network. Okay, I need to know the address of the router. You want to know the address of the router. Okay. Also the host must know if the router is alive. Also he want to know whether these routers are alive or it is functioning. The router solicitation and router advertisement message can help this situation. A host can broadcast or multicast a router solicitation message. The host will broadcast the router solicitation message. Uh, it will be received by each and every node that is connected by through this host. Okay, but the reply message by this router will be a unicast message. Clear? This is the explanation for this one. Clear? So this is called the reply query messages. Okay, this is called query messages. Now this Icmp, this is Icmp message format. Okay, this is the format, this is the packet format for that Icmp. Okay, ഈ Icmp message അയക്കുന്ന ഈ ഒരു ഫോർമാറ്റിലാണ്. Okay, the type ആണ് നമ്മൾ പറഞ്ഞത്. Type we have already discussed. This is a type. Okay, the type name is already written here. Type 8, type 0, type 13. If it is echo request and reply, it is type 8. Okay, the timestamp ആണെങ്കിൽ it is 13 or 14. Okay, clear? So this is the type. So the type of the message, the type numbers are in the message block diagram given above. Okay, the type is already given there. Okay, now code. The code field specifies the reason for the particular message. So why this message is being sent if any congestion occurred or error occurred. So the reason has to be specified. Okay. Now the checksum. Checksum is the for error correction mechanism, error checking mechanism. Okay. Then the rest of the header is specific for the message type. The rest of the header, this is the rest of the header, which is actually specified for the type of the message. Okay, for each type they can specify here. Then data section. The data section in the error message carries information for finding the original packet that had the error. So it contains the details of the packet that has the error. Okay, so those details will be present in the data section. Data section carries the information for finding the original packet that had the error. Error ഉണ്ടായിരുന്ന ആ പാക്കറ്റിനെ കുറിച്ചുള്ള ഡീറ്റെയിൽസ്. Clear? That is called Icmp. This is the Icmp message format. Okay, so this is the explanation for internet control message protocol. Clear?